This is a tag, TD. Oops. First of all, what's wrong with this tag if I'm doing XHTML?
It's uppercase.
What is this? What is this indicating? Yeah. What part of the table is it? Not the row. The cell inside the row.
Okay.
Table data.
Inside of what?
Table data. This is the cell inside the row. Now,
And row.
having said that, what must this tag be contained by? What do we have to find outside this tag? Or the other way of putting it is, if this tag isn't inside this X tag, it doesn't validate. So I'm looking for a tag that goes here. This is some sort of container that this table data tag has to be inside. What's this container?
TR.
TR. Cool. Now, why is that true? Why does it have to be inside of TR? Come on, Pat.
I cheated that one.
That's fine. So look it up a little bit more. Why does it have to be inside the TR tag?
Is it a table record?
The table row, table row, table row. But why does a TD have to be inside of TR? Any ideas?
Because the cells are in the row.
A cell is in the row. It's kind of common sense. This is a cell, and this is a row. And if you know tables, you know that these are TRs, TR, 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 TR. Closing slashes over here, TR, closing slash, TR. And then there's TDs in here, TD. These would be great if I could actually spell. TD, TD. If there's a two-column table, and I'm not showing you the closing tags, then every row has two of these cells in it. That's how you make HTML tables. It's all coming back to you now, right? What tags do I use for this row? Matt's looking it up, so you can't answer this one. You have to, computer. You could be, cheating your way to glory too.
Header?
Pardon me?
Header?
Okay, what's the tag for that?
H1.
No, she had a TH. H1 is a header, but it's not a table header. So this is TH. What goes inside here? And how do I put the heading on these columns? What goes inside there? Give it a shot.
I don't know. I thought I did, and
Okay.
I'm blank on it.
Your tags.
It's the heading row, and each column in that row needs a header and needs something in the cell. So what do you think you might put up there? Let's take a while.
HR.
Yes, ma'am?
HR.
HR? No. It's a table tag. I'll give you that hint.
TD.
TD. Touchdown. You bet. TD. Now what is different about these TH things? If you find something in a TH, how is the browser going to render that differently? First of all, what do I mean when I say render? When a browser renders something, what is it doing?
Showing it.
It is displaying it, sure, it's showing it. It is not boiling it down to liberate the fat from the tissue. And although you think so, seeing how some browsers render page. So what is typically, if the browser is using its internal default style sheets, how does it typically render the header row of the table? Or is it just exactly the same?
I'm pleading fifth.
What do you guys that's in front of a computer, look it up on W3 Schools. Tell me what the difference is in a TH. Yeah, usually it's bold. Usually it's a different style. It's an example of how browsers have a built-in style sheet. So that if you don't supply styles, the browser will do it for you. Typically, the browser has a really ugly-looking style sheet, although they're getting that. Okay, finally, the last question I have around tables is all of this is contained within tag pair.
Body.
That's true, but closer. What is the, yes, all of this is in the body of the page. What?
Paragraph, P.
Not necessarily. What has to be just outside this?
Table?
Yes. So just outside this, if I had something, for some reason, I had a table that only had one row with one cell, this would be a legal table. Now, what's wrong? What's wrong with that? Sir?
It's not nested, it shouldn't have.
Not nested correctly. Shame on me, no validation cookie for you. Is this legal HTML?
No.
Yes, unfortunately it is.
Not XHTML.
Not XHTML. Yes. So this is not good. XHTML because it has bad nesting. Yeah. Okay. There's three parts to every web page. Three parts. There's the HTML, the structure, these tags. There's the structure and the content, and that is in HTML. That's an HTML file. There's something in files called .css. What is in the .css files? What element, what aspect of the web page is in
Style.
the style?
Cascading.
These aren't tough questions. These aren't. So that's the look and feel, the fonts, the colors. Now there's another aspect of it to read. There's the behaviors. What kind of file comes in, carries the behaviors? JavaScript. And typically the extension for a JavaScript file is what? Not JS. These are all the resources. An HTML file can link to other kinds of files. Give me examples of the other kinds of files it can link to. What other stuff can you bring in on and display on a web page? You've done this in your homework.
Other websites.
Other web pages, great. So I can, what's the link I use? What's the tag I use to link to another web page?
HREF.
That's the attribute in it. What tag is that attribute in? Yes, what do they stand for?
Anchor.
Yeah, great. What's something else I can link to inside an HTML page?
Pictures.
Pictures. What's the tag I use for that? Image source. So that's IMG SRC equals, and then all those always putting these things in quotes? The value to an attribute, why am I putting that in quotes? Any idea?
Cause it's a string?
It's a string, and strings must be quoted in XHTML. The old sloppy way of doing things, they let you get away with not quoting your strings. We'll come back when we talk about strings when we talk about programming. Now, we haven't hit this yet, but you can have styles inside your HTML. Remember, where are the styles in your journal file right now?
They're up above the body.
Above the body, yeah. So you can have styles inside your HTML file. What's the tag you use for that? Anyone? What tag stores style information? Style. Isn't it weird when nerds actually say something obvious? What, you mean it's not the flabbergasted tag? Yeah, because the style tag usually contains style information. Now you can either have the style information right there in the file with you, or you can have it in an external file. We'll actually do that in a subsequent assignment. And we'll actually put some JavaScript in later. The important thing for you this week is to know that HTML is the structure and the content. You may find mentioned somewhere in the test that you can put style information in the tags, in the attributes of the things like center, align, equal center, that sort of thing. That's HTML syntax. The new modern way of doing things is you put all of your style, all of your alignment, all of your fonts, colors, and all that sort of stuff in your cascading style sheets. But you'll still find plenty of pages out there on the web that are mixing the style in with the HTML. I can't say that one is wrong, but going forward, if you ever have the chance to do a new project, or if your job has you improving old web pages, take the style information now and put it separately. Why is having style information separate from structure and content a good idea? Any ideas? Yeah.
When you change it, then you only have to change the style, you don't have to mess with the rest of it.
Yes, that's a very good reason. That especially is true if you take your style out and put it in a file and then you have all your pages look at the same style. Because then if you want to change the font on your whole website, you just change it in one spot. Another good reason has to do with assistive technology, where you've got a web browser that talks to you, that reads to you. That web browser doesn't care what font it's in. It cares about the semantics. That is the meaning of what you're putting in the page. Because that way, when you're having this conversation with a web browser and you say, skip to the next section, the web browser just goes down, looks for a heading tag, and starts reading from there. So, when you do markup, use HTML for what you're talking about, the actual content of your page and what it means. Leave all the style stuff, like the alignment or the fonts or the size or the bold, leave all of that to your side. Any other questions about HTML? So, you did an assignment where you had a hover effect, remember? And you used a technique for what? Changing the opacity of the image. If you recall, you used a selector, a pseudo-selector. That ring any bells? So let's take a look at a cascading style sheet rule. So the first thing in a rule is a selector. And then there's angle brackets. And then there's rules in here. There's couple different types of selectors. Couple different types of selectors. So, the easy one is just the tag. So if I want all my paragraphs to be Times Roman font, I would have a rule that said P. Is it font face or font? I think it's font. And that says for everything that's tagged with a paragraph tag, I want you to use this one. So the first kind is the tag. The second one is the ID. The next one is the class. And then the last one is pseudoclass. Which of these four did you use to create the hover effect? Anyone remember?
ID.
No. Okay, so the pseudoclasses, yes,
No, I said, I thought it was a tag, but I guess.
remember, because the selector you had was colon hover. And then you had opacity, I
Oh.
believe. Is what, 40%? So this is your selector, this colon hover. This was the attribute and this was its value. This is an example of a pseudo-selector. A pseudo-selector. This means whenever I hover my mouse over an element, then make its opacity 40%. So a pseudo-selector is a selector that is responding to conditions. Later on, you'll have a way of, I want you to change the color of links that have been visited. Or links that you're hovering over the link, I want it to change color so you can easily tell what's clickable and what's not. So, in CSS rules, selector is the thing that says, this is the thing I'm pointing to, and I want it to have this style. This is the style rule I have. Rules are attributes plus values. 4 different types. Tag. That means everything that's tagged like this, like every TH, is going to be bold. So the style that makes all of my heading, all of my table headers bold is, how about turn something bold? You've got a computer. Is it font face? So the Google selection could be W3 schools, CSS rule, bold face or something like that. No, it's bold here. I don't want to call it font, I want it blank.
Now, a question for you on the way that you're structuring like hover opacity 40. They don't have to be on individual lines, do they? Or why do they do that, like 3 separate lines?
That's it. Font weight. Font weight. Why do I put it on separate lines?
Correct.
Yeah. This is a real simple rule. But when you get more complicated, you can have 5, 6, or 7 rules associated with a particular thing.
Okay. Because I just made mine all one line because it was easier for me to read. I could see that I had all my tags in the proper space and it still validates, so.
Yep. And in fact, what you'll find is that if you've got a page that a lot of people are downloading, every byte counts. Because you want that page to load as quickly as possible. And every byte that you have to ship from your server over to the client costs you time and bandwidth, which means money. So The files that actually get put into production, typically they cut out all of the character terms. They'll even take, like if you can name your classes and IDs anything you want. And when you're developing it, typically the identifiers are big and long so you can remember what they're good for. You don't need all of those characters. So usually what happens is there's a program in your toolkit that takes these style files and compresses them. Takes all the names out and replaces them with little tiny names. Takes all of the character terms out and squashes everything together. Makes it very difficult to read, but it makes the file much smaller. And then they usually zip the files after that, so that the files that are actually being sent to your customer's browser are tiny. And they call that obfuscation. It's one of the steps, is obfuscation. This is not on the exam. But if you're a modern web designer, you're constantly thinking about this. The thing you should never do as a modern web designer is write really compact, silly, tiny little names. You should never do that, because it makes it hard on the humans to try and understand what you're doing. It's just like when you're writing code. You don't use, like we talked about in terms of naming tables or naming attributes, use big long names. It's okay. Because it's more important for another human to be able to understand what you're doing than it is for you to save a few bytes. And these days, before you put it into production, you're going to run it through a cleaner anyway, and it's going to squash all that stuff down. Okay, this is enough about style sheets. Style sheets, CSS files, have a bunch of rules in them. Each rule has a selector and a bunch of attributes associated with it. Those selectors point to specific parts of your HTML, either by tag, by ID, by class, or by what the HTML is actually doing. All right, we won't go over JavaScript because that's in the second half of the course. So that's about all I remember. Geez, there's got to be more to the HTML part of this class than that. Wow, tables, links. Oh, relative addressing. Oh, yeah.
So you would absolute.
Relative addressing. Pardon me?
And absolute.
Relative and absolute. So, Rob, tell me what absolute addressing is. If I have an absolute address, it tends to be longer than a relative address.
It's the entire address. I'll put more, it's the entire address, including www, everything that goes on.
It has everything in it,
Yeah.
including things like the protocol you're using, HTTP. What is the www.pcc.edu? What is that piece of it? Richard?
It links to an external website. I mean, it's
An external website, that's the name
That's
of the
a
website. Domain name of the website, cool. So an absolute address contains the protocol, the name of the website, the whole path down to the file. It will work from anywhere on the planet. It's a uniform resource locator. What's a relative? Specifically in a relative address, when I write something like this, picture not JPEG. In fact, I'm going to make it even weirder. So my image, src equals quote, close it off. What was wrong with that? There's something wrong. Need a closing slash. This is XHTML. Closing slash, closing slash, closing slash. I want to draw a tree that gets me from where I am, the current HTML file, to this picture file. So I'm somewhere in the tree, and here's a file, here's a folder, inside here is a file, and here's my file.html. This is where my link is. So now, help me interpret this. What do these two dots mean?
Go up.
Go up, young man, go up. So I'm here, which means I have to go up to here. So now I'm at this level. What do the next two dots mean?
Again,
Go up again. So now I'm at this level. This is some folder somewhere. This is some folder somewhere. Whoop, whoop. Now I'm up here. Now what do I do? I'm taking care of this. I'm taking care of this. What do we do with this thing? What does this mean?
it's in the image folder.
There must be a folder up here somewhere. And it must be called images. And it has what inside it?
Picture JPEG.
Okay, so spread this out across the field. To get from here to here, I went dot dot to here, dot dot to here. No, this is a mistake.
Yeah.
This is a mistake.
Too many,
Too many dots. Too many.
files.
Yeah. This is not here.
Should have been.
It is here. So I go one dot dot, two dot dots, images, picture.jpg. So I went all the way through to here. Now why do I bother with this? Why do I use relative addresses?
So you don't need the entire address.
So I don't need the whole address, it saves me typing, it saves me space, that's true. But the other reason I do it is I can take this whole thing, I can take this whole tree, and I can squirt it up to a server. This URL will work on my PC, it'll work up on my web server. If my web server admin decides they have to move it somewhere else, for reasons of their own, it will still work. But this relative addresses allow me to use to treat the whole website as just one big thing that I move around. It's very important, very important. So that's absolute versus relative. Little thing. Is that a legal XHTML tag? XHTML tag, is it legal?
I say yes.
No, it is not. Only one gentleman's up on top of this particular thing. XHTML always has to have a trailing closing tag. Now this is tedious. This is horribly tedious. No one wants to type this in, even though it's perfectly legal. So there is this form of this tag. This is not legal. This is legal. This is legal. It's important for you to know that this is just a short form of this. There's another tag like that. Can someone give me another example of a tag that has it that closes itself?
Paragraph?
No, a paragraph is a container. It contains something. This is not a container, this is just a break. This is an example of a tag that closes itself. An image doesn't contain anything, it's a link to a file. Another example of a tag that closes itself is, how do you make a horizontal rule? How do you make a line?
HR.
H-R. And closes itself. There's always a space here. There's always a space here. Always a space there. Okay, self-closing tags. Self-closing tags. XHTML requires a closing tag on every tag. Sometimes that's too much even for the purists among us. So in a few cases, they allow us to close the tag immediately. That's only for tags that are not contained. Everything else contains something. There's the opening tag, there's a bunch of stuff, and then there's a closing tag. They're all called containers. All right, let's switch to databases. Let's do a whirlwind thing with databases, and then I'll stop people with questions and we can go home. Get ready. What does ERD stand for? ERD.
Entity relationship.
Entity relationship.
Design. Forgot the last letter.
Lucky for you, your classmates have it down. Entity relationship diagram. Why are they called entity relationship diagrams? What are entities? It's a noun. Noun typically describes what? Things. So, is an invoice an entity?
Yes.
Is an eye color an entity?
No.
What is an eye color?
Attribute.
Attribute. What? Why is your eye color an attribute and you an entity? Anyone have any good ideas?
Eye color describes something about the
Yeah. Now, if you were making a database for people who make glass eyeballs, eye color might be an entity. Because then it's so important to the design of the database that you need to be able to map for it. So that boundary between entity and attribute is kind of flexible. But an entity is a thing that you want to track, and an attribute is a characteristic of that thing. What's a record?
It's a tuple?
Cool. And it was great, everybody in the room was like, yeah, but that doesn't get me any closer to knowing what we're talking about. What are we talking about? What's a record?
So,
It's a row in a table. What does it represent?
A group of related attributes.
A group of related attributes, and what does that group of related attributes represent? One particular entity. You guys have got this down. Oh yeah. Okay, so we got tuples. I love the word tuple. I really do. What is the thing that you take? How do you implement an entity set? When you have an entity set, what do you put it in your database? Yes, you put it in a table. You don't have to ask questions. You can just say, it's a table, table, it's a table. Go, darn it, it's a table. That's exactly what I'm talking about. So in that table, we've already said that each row represents a particular entity, and all of the values of the attributes are in that row. What's a column in the table?
Attribute.
It's the attribute in the abstract. This column is always filled with, I don't know, first name, last name. The cell in that column is the particular value of first name of that attribute for that particular record. As an aside, if you've done any kind of object-oriented programming, the table represents the object class. The row represents the object instance, the object itself. These are all related concepts. As you go through computers, you'll see we use the same concept over and over again. We're not very original thinkers. At least not when you get to the point of IT. If you want original thinking, get yourself a PhD in computer science. And you'll be thinking so originally nobody knows what you're talking about. A good table has primary keys that have certain characteristics. A good table has primary keys that have certain characteristics. First of all, what's a primary key in a table? Yes?
It uniquely identifies each record.
Yes, it's a unique identifier for each record. Can you make a primary key out of attributes? Like, can I make a primary key out of like my name, my address, my G number, and my shoe size?
Yep.
When I do that, as long as it's unique, it's a primary key. When I do that, it's a particular kind of primary key.
Composite.
It's a composite primary key. Now we're gonna have to shut him up because he's just answering the questions you guys. So I need you to, someone to smack the next time you raise his hand, so one of the rest of you, because I know the rest of you just really want to answer these questions, I can tell. like, oh, Richard, shut up. Yeah. So we've got these primary keys. What's a good primary key? It has, well, first of all, what does integrity mean to you? Integrity. When I say that man has integrity, what does that mean?
Can I answer?
No!
Okay.
Richard, you cannot answer anymore. In fact, you're on a timeout for the next 5 minutes. Good student, timeout. What is integrity? This is something, you know, when someone says you don't marry that idiot, he has no integrity. Your mother knows what integrity means. Because I'm sure she said that too many times, right? Don't marry that guy, he has no integrity. And you're saying, come on, he's a guy. Really, what does integrity stand for? What does it mean?
I know what it means, I'm just trying to figure out the best way to put it in words.
Just say it. If a guy has integrity, what does that mean to you?
I'm sorry, say again?
If a guy has integrity, what does that mean to you?
Yeah, you know, there's no surprises, you know, this stands for, information, what he says is clear, you can
Yeah.
go on.
Trustworthy,
Yeah.
you know what you're getting, there's no surprises. So if a primary key has integrity, you know what you're getting. You're always getting something you can trust. What is the technical name for the type of integrities that primary keys have? Close. So close. No. Go ahead. You have another 3 minutes. So, if you've got a good primary key, it always pulls up the entity that you think it will. It always pulls up the right entity. So a good primary key has entity integrity. It always is going to, you can depend on it to select the right entity. Now, it's not necessary to have primary keys that are unique. Well, no, it's always necessary to have primary keys that are unique. It's not necessary that they are auto-generated or auto-numbering. But if they are auto-numbering, what advantages do I have if I use a generated primary key that is auto-numbering? No, you can't say it. Anyone else? You used auto-numbering, auto-generated primary keys in your access files. Why?
Always be
You can depend on them to always be unique. The program itself makes sure that they have entity integrity. Okay. Now, if you remember entity relationship diagrams, I had one spud over here and I had another spud over here. These are represented by entities. Every dog has its day. So that implies that every dog has a relationship to a day. Probably all sorts of relationships between dogs and days, like dog day afternoon. But every dog has its. Let's say that every dog has one and only one day. You have a couple of choices. You can use this symbol, you can use this symbol, you can use this symbol, or you can use that symbol. Every dog has one and only one day. Which symbol do I use? Every dog has one or many days. Every dog has, well, it might have a day, but if it does have a day, it only has one. Yeah. When do I use D? When do I use D? When I don't know. When I have no clue what the deal is with dogs and days. Someone says to me a dog has a day, I think, fine, I'll connect it. Tell me more. Typically, this is the dog has one day, but you never know. Is it legal to say a dog has 0 days, or maybe it has one and only one day?
No.
You say that? No. Make up your mind. Either it has one or more, or it has 0 or 1. Is it legal to say A dog might have 0 days, 1 day, or it might have a lot of days? No. Usually there's only 2 things here. There's 1, 2 things, 1, 2, 1, 2. Sometimes there's only 1. Sometimes there's only 1. But there's never 3. Never 3. Okay. These symbols show 2 characteristics. 2 characteristics. Alities. Cardinality and optionality. Very good. My heart sings that someone is paying attention. Whoa.
Cardinal fingers.
Cardinal what?
Call them cardinal fingers instead of crow feet.
Cardinality. What does cardinality mean?
How many?
How many? Exactly. Cardinalities. How many? Optionality. What does that mean?
It's required.
This is required. Exactly. So these 2 concepts combine and you can draw pictures of them this way. This thing always has a label. In one of the notations, you've seen 2 different notations in this class, one with the diamonds. The one we used was it had a label. It has, actually it has its, and then the other one belongs to. This diagram represents 2 business rules. Can someone tell me one of those business rules?
The dog has its day.
Dog has its day. What's the other business rule? Yeah. Great. So, now tell me those business rules again, now that I've shown you the optionality and the cardinality. So what's the first business rule?
Every dog has,
No, there's nothing about every here.
or dog has its day or not.
Yes. One day has either 0 or 1.
1 day.
A dog has either 0 or 1 day. Or some dogs have their day. And if they have a day, they get 1 day. What's the other business rule? Yep. It's 1 lucky dog. 1 lucky dog. So somewhere on the planet there are 365 lucky dogs. Now notice that neither of these business rules are every dog has its day. For that, what would I put over here? Right? Yeah. So lots of dogs have their day. And there's no optionality here. Every dog has its day. So there's no optionality about it. Every dog has its day. Okay, so that's the review around that. Entity relationship diagrams. Entities, relationships, these weird little symbols. Pam.
On our test, it asked what symbol was for entities and had us choose rectangle. If we chose oval, it was wrong.
Yeah. Point that out to me when you come around. If you get that again and it gives you the sort. So what she's saying, obviously, there are other kinds of entity relationships. You've seen them like this. And another kind, I've seen it where they say it has, instead of these weird symbols, you actually put in numbers here. There's lots of different entity relationship diagrams. In this course, your assignment had to do it this way. If you turned it in this way, I was fine with it. All right, entity relationship, primary key. Oh, now, finally we'll get around to that answer you had earlier. If I want to relate dogs and days in terms of tables, I've got a table for dogs. I've got the primary key for dog, and whatever set of attributes dogs have. And then I've got a table of days. There's a primary key for days. Dogs. Now let's say that in our little universe, a dog has 1 and only 1 day, a day can belong to many dogs. So that's the way this example is going. How do I connect these two tables? Foreign keys. What's a foreign key? Foreign key in one table is a what in the other table? Very cool. So which table does the foreign key go into? Which table has an attribute that says this is the foreign key? So we know that a day belongs to many dogs.
Goes to the dog table, because it's the many side of the.
So the dog has the foreign key for days. We're going to just call it days. Now, you'll notice there was inconsistency in the material. Sometimes I was telling you that you have to use exactly the same name. Sometimes in the material they use a different name. Blah, 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 blah. If you hit an exam question that makes you land on one side of that, you don't like how you landed, and scores you wrong, let me know. So, I've got a foreign key here that points to a particular day. This is the day that belongs to that dog. And another dog could have the same day, and another dog could have a different day. One to many. One to many. The foreign key goes to this thing. Okay, now how do you know you've got a good foreign key? You heard the answer earlier. Referential integrity. That means there's no broken links. You can depend on these references. Every reference points to something useful. It's a trustworthy reference. Referential integrity. Okay, this is the last two concepts. When I say there are transitive dependencies in a table, transitive dependencies in a table, what does that mean? Inside a record, something's wrong. Go ahead.
It's a dependency between two attributes other than the primary key.
Yeah, so something inside the row depends on something else inside the row, except it's not a primary key. Why is that wrong? It's a very simple answer. Why is it wrong to have transitive or that kind of dependencies inside a row?
Because then it's not broke down as far as it can go.
Yeah, it's not as simple as it can be. We're heading for Occam's razor here. We want to make things as simple as possible. That process of making a table as simple as possible has a name.
Normalization.
Normalization. It makes sure that every piece of the table is independent of every other piece of the table. It's as simple as possible. Now, I may end up with a simple set of tables, but I end up with more tables or fewer tables?
More.
Yeah, so the process of simplifying each table usually happens by pulling stuff out of that table and putting it into its own little table and attaching the two with a form. So that's the process of normalization. There's how many levels that we're concerned about in terms of normalization. Okay. First normal form means what? Yeah, if you're not looking at your notes now, I don't know what, because I couldn't remember this.
You have entity and integrity.
All it has is entity integrity. You can depend on the primary keys, you can depend on the primary keys, but you can't depend on anything else. Second normal form is primary key integrity plus.
No.
All of that one.
Pardon me? And I don't know the answer to this.
No
I'm
partial
asking you guys to know.
dependencies.
That's it.
No partial dependencies. Which means if you've got a composite primary key, you don't have dependencies on a piece of the primary. Another reason why composite primary keys get you. Third normal form.
No transitive dependencies.
And where does referential integrity come in? Second normal form? Does it come in at all?
Doesn't come in at all.
Alright, so primary key is entity integrity is first normal form. Second normal form is primary key integrity plus no partial dependencies. Third normal form is primary key integrity, no partial dependencies, no transitive dependencies. Have we got this right, Dan? You're checking
Yes.
this? Okay. Are there more normal forms?
Then it goes to 6.
There's 6 of them somewhere. Does anyone care? You betcha, DBAs care all the time. We don't in this class. If I'm in third normal form, am I in second normal form?
Yeah.
Yes.
No. No.
I thought you had to go
You have to go through second normal form to get to third normal form, but you are not. If I'm in high school, am I also in junior high?
No.
If I'm in junior high, am I in kindergarten? So think of it that way. Don't think of it as, yeah, right. Yeah, if you're in business, you need a lot of people that appear to be in kindergarten. You just have to take a nap, put your head down on the conference table. No, just think of it like grade school, junior high, high school, college. If you're in college, typically you have to read as well as a first grader. Although you all have run into people who, for that was not true. But if the system worked, if you were in college, you'd have to have all the skills of a high school student. If you were in high school, you'd have to have all the skills of a grade school student. That doesn't mean that when you're in college, you're in grade school. So when you're in third normal form, you have to have all of the qualities of first normal form and second normal form. But you're not in those things. They're not overlapping sets. This is on the exam. That question is on the exam. Why do I beat it like a dead horse? Because that's one of the questions that everybody got wrong the first time they taught this course. It's an important concept. Okay, so what other things are important about databases? Nothing. There's nothing else important. Sure, if you remember all this, there's got to be other stuff. So we've gone through, in terms of databases, let's summarize. We've talked about what a business systems analyst does, a BSA does. They ask questions, they find out the nouns, the verbs, they figure out the nouns are entities, the verbs are relationships, they figure out all the adjectives, blue eyes, late invoices. They use those adjectives to figure out what the attributes are of an entity. They create 2 artifacts. They create entity relationship diagrams, they create business rules. Then we transform the business rules and the entity relationships diagrams, we transform those into tables. Tables have rows, tables have columns, tables have keys, primary keys, foreign keys. We use the relationships and the cardinalities and the optionalities that we discovered while we were doing our interviews. We use those to figure out how we're going to connect our foreign keys. And then we start to use aspects of a good database engine to make sure we have good quality. Quality is things like primary key, entity integrity, foreign key, referential integrity. We end up with a database that has 2 qualities: effectiveness and efficiency. A database that is effective allows me to do what? Why is that a good measure of quality? Effectiveness.
If it's not effective, why use it?
It's something else. But if it is effective, then you can depend on it. It does its job. It does its job. Now, if it's efficient, what does that mean?
It pulls the data quickly.
It does its job well. So we've all had coworkers that do their job, but they're not the best worker. They just kind of do their job at some minimal level. So you want a database that is both effective, namely it does the job, and it's efficient. It does the job quickly. It does exactly what you asked it to. These things are different for different kinds of applications. Remember, we talked about 2 types of databases. There's the type of database you might find with Fred Meyer that is helping you check out quickly. And there's the kind of database that you do big, deep searches where you're trying to figure out answers to complicated questions. What are the 2 types of databases called?
Production database and
That's one. No, I'm looking for something else.
um,
What's a database that has to do each thing quickly? Something that you're doing business transactions with. I can take here. kind of database that does transactions.
Transactional.
Yeah, see, I'm not a really dumb guy. And you know, I'm gonna have to confess, I don't know the other word. But there's another word for databases that allow you to do deep queries. So someone's gonna have to look it up, please. Decision support's a name for it, but isn't there another word for it? Yeah. So in those cases, well, let's just use decision support. That's a situation where you've got a lot of data and you've got to do complicated queries and you want to figure out the answer to things. It doesn't really matter that it comes up with those answers quickly. It just has to be very well organized. You have to have a lot of really good attributes so that you can rank it. Transactional databases have to do updates really quickly. I have to be able to pull stuff out, put stuff in really quick. It's a different measure of efficiency. One is just fast, one is deep, one is complicated. All right, what's a query? What's a query?
Search.
It's a search. That's a kind of query that pulls stuff out of a database. Are there other kinds of queries? CRUD. Does anyone remember what CRUD stands for? CRUD. The kind of stuff we're learning in this class, that's what it stands for, CRUD. Create, update, delete or destroy, and it's just read. So these are the different kinds of queries. The most common one, the one that does searching, is a read query, where you say, I want to ask this table, show me everything that has these kind of attributes, show me everything that has this combination of factors. And I want to read that stuff out of here. There's another query that says insert into the table, put this record into the table. There's another kind of query that says pull a record out that has these attributes and now change one of these attributes, put it back. And then the delete or destroy is obviously find me a record that matches these attributes and blow it away. So queries take different forms, but queries are the way that you get stuff into and out of databases. Queries are the way you get stuff into and out of databases. There's insert in SQL. Insert, I think, what is this one? Select. Some of the verbs. Typically, what's the user interface for a query? What's the piece that the human interacts with? If I want to plug something into a database, what do I use?
Access.
A form. Access has three things that you've had to create just recently: the queries, the form, and reports. What's a report?
It's the output.
It's a bunch of records. If you do a query, it returns a bunch of records, throw them into a report. Are forms used for just input? No. I hear angel. So, forms can be used for both input and output. A form typically contains just one record, but as you saw in assignment 3, a form can show you more than just that. Forms can be pretty complicated, and forms are the basis of interactive websites. And as we saw, there's lots of patterns for doing forms. Sometimes forms can be very simple, just one field. Sometimes when you click on a piece of text, it turns into something that can change. Behind the scenes, it's actually turned into a form. So forms, queries, forms, and reports. And I do believe that's the end of the thing for databases. So we covered HTML, web design, CSS. We've covered databases, and then all sorts of stuff about that. I think that's all you'll see on the exam. The exams is available again when?
3 p.m. tomorrow.
Thursday on Thursday. When does it close?
Friday at 3 p.m.
Friday at 3 p.m. How many times can you take it?
Twice.
How long do you have each time?
2 hours.
2 hours.
3 hours? I may open that up to 3 hours.
Wow.
I don't know. I probably have to.
It's too much.
3 hours is too much?
Yeah, because then I start questioning myself and I go back and I change answers that were
Well, I
right.
don't, man, just submit it.
That brings up one last thing, and this isn't really part of this particular class. Some of you guys are just starting out in school, this is your second quarter. For some of you folks who have been in school longer, what's a good way to take a big test like this? Are there some tips? When I was in college, I nearly flunked my first semester. In fact, I did flunk almost all my classes in my first semester. I crashed and burned. I came home, my mom was yelling at me, she's Irish, she was really yelling at me. Spending good money, and I was expecting my dad to let loose like a flamethrower on me. He was just real quiet. He finally says to me, "You gonna fix this?" And there's no one answer to that, right? I'm like, "Sure, yes, I'm gonna fix this." He says, "Good. Let me do one more report. You fix this, and then we won't worry about it." Well, I walked out. I thought, "How am I gonna fix this? How am I gonna fix this?" Luckily, I had an older sister. Thank goodness for older sisters, who was in college at the time. And she sat me down and she gave me the rules for being a success at college. There were only like 5. And they were as good as, I think I've told you guys this story, they were as good as the rule she gave me when I started dating, which is don't wear white socks with black shoes. It's a good rule, it's worked for me ever since. But that was the only problem I had with women up to that point. It was the white socks. Who could we? Anyway, so what are some of the rules for good test taking? Anybody?
Go to the bathroom at a time.
That was my sister's first rule. Take a good dump beforehand. Get that off your mind. But aside from that,
Go with your instinct.
go with your instinct. Yeah. Answer the questions you know first. If you know what you're talking about, your first instinct is probably true. You probably know what you're talking about. Save the ones that you don't know till later. What's another one?
Don't spend too much time on one question.
Yes, you only have so much time. You've got a lot of questions. The more you obsess about questions, the more likely you are to get them wrong. This test system scrambles the answers, the multiple choice answers. So if you're one of those guys where you think, oh, you look at those Scanton pages, you think it has to be a random distribution, and I've answered C the last 3 times, it's got to be something else. That's not true in this class. You have no idea how the test is going to present the question to you. So I wouldn't look for patterns. It used to be that you could look for patterns. Any other questions? Any other suggestions? It's open book, but again, the tip is pay attention to our materials. And frankly, if you get a question where there's some discrepancy between what I've said and what the materials say, and you can see it there on the page, you bring it up and it's then, one of the readings says, this fact is this, then it's probably going to be paired up with the question. If you ever run into a situation where you say, in class you said this, the material said this other thing, I answered the question this way and I got it wrong, but you told me this was the thing, send it to me. To me, that's a bug in the class. Anything else? Any other questions? All right.
Oh, maybe I can talk to you after class or something, but I'm still kind of confused on the heading on the table, or not the table, but the heading on the heading on the table with the HTML, why it's TE in the heading to make it bold. I'm not sure if I.
It's the heading row itself, the TH, that influences the whole row. Have I got that wrong?
I'm not sure, but it's TH and then the end, the slash TH, but in the middle it's TE.
Oh, the TH is the header sound. Richard, you are a genius. No one questioned me in this class, you'd end up idiots. Sorry, and you are idiots. So what is the way it should happen? How do you do a real header of a table?
I don't know. I'd have to look at it up. That didn't make sense, I just wasn't sure.
So TR. Sorry folks. So this is a 2-row table / table. Header opening, closing tag. It's got 2 columns. I'm making a table that looks like this. So in here I have TH. Close TH. TH. Boom, / TH. Open TD. Good. So this header tag makes these bold. Makes these 2 things bold. It also tells those screen readers that these are column headings. These are column headings. These are just cells in the rows. Making sure I got that right. I'm on the W3 schools. I'm looking at the HTML tag.
But it only makes it bold because of the browser style.
Right. That means the browser has a default style sheet, and the TH selector has a rule that says font weight bold. So the default browser default style sheet has this rule in it.
So if you were to want to not, for that to not be bold,
Right.
then if you were to mark in your code that you don't want it bold, then that would take preference over the default.
Yep. And we won't worry about that now, but we'll talk about the cascade. That's what cascading refers to. That there's a hierarchy. That if you put the style rule some places, it overrides the style rules the other places. And that browser default gets overridden by everything you do. So if you put in a rule anywhere that says, I want my table headers to be font weight, I don't know what the other legal values are.
Italic.
Okay, italic. Let's say you do that, then the browser isn't going to make you bold anymore. It'll ignore its own style and it'll use yours. That's why typically designers have a set of rules that they call a browser reset, which basically turns off all the styles so that they don't have to worry about what the browser default is. They just remove any other styles. And then they build it from scratch. Other questions? Come on, Richard. Find another bug. You can do it. Sir, you lied again. I lied. Really, W3 Schools is your friend. It's a very complicated site, and you have to make sure that you're looking at the XHTML part of the site rather than the HTML part of the site, rather than the HTML5 part of the site. You're concerned about XHTML. When you create stuff in this class, you have to know the difference between HTML. What is the version we use? 4? Say we use 4.1, or you can use XHTML transitional 1.1. By the way, the longer you sit here, the more questions I'll have for you. Those 2 things, where I said it could be HTML4, it could be XHTML1, where do I tell the browser which of the 2 things I'm using?
Doc type.
The doc type. What's the doc type?
The document header.
And where does it go on the page?
Very
Very
first.
top.
Does it go inside the header? Does it go inside the head? No, it goes before the head. It's metadata. It's data about data.
It's in that top part of the top.
Where do you tell it what character set you're using? But everybody had a validation error that said, wow, what's the UTF-8 thing? I'm assuming, that's this. Where does that go? You go two places.
Like you said, you do your meta tag.
You can put it in a meta tag, or you can actually put it in an XML declaration up at the very top. This is weird arcane stuff at this point. I don't expect you to remember it, but it'll be something you may have to look up. Yes.
Refresh on, what's a hierarchical database?
Boy, I don't know. You'll have to know, but I can't tell you what it is.
Okay.
I don't know. I've never used a hierarchical database. I doubt if you get a job in IT, you'll ever use a hierarchical database.
It was just one of the questions.
Yep.
It was the wrong part of the answer, obviously.
Just like I have never worked with Grace Hopper, you should know who she is. One of those things. I wish I could tell you what a hierarchical database is. I can tell you what an object database is. More questions. Let's play Stump the Chump. You ought to be able to give me a question I can't answer. You've done it 3 times today. Okay, that's all I got. Yes, sir.
If you don't mind me interjecting, if I could, regarding the hierarchical database, I believe it's like, an example would be like the company, you know, they got the main company, and then there's, like the departments, or there's the branches, and then there's the departments in the branches, and then to get to the branch, you have to know the path to get to that branch.
So
You
you
can't
gotta go
just,
through each database to get to the next.
yeah, you have to know how to get to there, to get to that location, as opposed to relational, where you just look it up by the primary key. I believe that's,
So a hierarchical database, the entities are related by a predetermined hierarchy.
yeah, kind of like the relative absolute address, you know, it's got to be a certain,
So I could implement a hierarchical database using a relational database if I define the relationships the right way.
yeah, if you defined it with the path, probably, you could probably.
Okay, cool.
But according to the materials, it's pretty inefficient.
And there are only so many things in the world that are strict hierarchies. I mean, even a corporation, they always tell you there's an org chart, but you find out for yourself who gets things done, and who's in charge. And sometimes it's not the person above you in the org chart.
Usually the person below you.
A lot of times. But discussion of power networks and transitive values is something for an MBA class, not for this. Anything else? Fine. Give me another question I can answer. I love those. All right, folks. I will see you next Tuesday, and I'll be paying attention next Thursday. Good luck.
Hey, thanks.